So, in last class I have shown you the spectrometer, prism spectrometer. So, what I have showed in last class, so basically this as I showed you that three components in this spectrometer: collimator, then prism or grating table and telescope. These are the three main components. So, this is the collimator, this is the collimator, this is the prism table or grating table, and this is the telescope. These are the three major components. So, what is the requirements for doing experiment using this spectrometer? So, requirements are this: we need parallel rays, means say you have prism on the prism table. So, parallel ray will fall on the prism. So, we need parallel rays incident on the prism face, right. So, these parallel rays we will get from the collimator. So, collimator is used to produce the parallel beams which will incident on the prism or grating, right. Then prism by dispersion, prism has capacity of dispersion, means when white lights will fall on the prism, then other side all colors will be separated, all colors will be separated. Generally when we draw ray diagram, then we take one ray falling on it, white light ray, and then after refraction due to dispersion, so these different colors are separated, right. So, for beam means not a single ray, there are many rays, they are parallel rays. When they will fall on this prism, so other side each ray will give different color, or each ray, from each ray the colors will be separated. So, other side if from each ray you will get this separation of each color, So, if you look for a particular color, so basically other side this particular color rays are parallel, okay. So, basically other side you will get different sets of parallel rays of different colors. So, now we want to see basically image of the source, okay. So, other side due to the effect of the prism you are getting the parallel rays of different colors, okay. Now, to see the image of the source, so these parallel rays they have to meet somewhere, right. So, where they will meet parallel rays, they will meet at infinity. So, you will see the image at infinity, but in lab in a smaller space, if you want to see the image, then we use this another part of the spectrometer, that is the telescope. So, function of the telescope is to converge this parallel rays on the screen, there it will form the image, and that image we will see through our eye. So, in telescope, this is the function of telescope to form the image, right. So, these three parts: collimator, which is basically producing the parallel rays which will incident on the prism. That is the requirement of the experiment. Other side, after the dispersion, you will get parallel rays of different colors, okay, set of parallel rays of different colors. So, to form the image, we have to, so this parallel rays has to diverge, converge, okay. Otherwise, it will converge to the meet at the infinity. So, in laboratory to converge them, we use the telescope, okay. So, in collimator, how we get the parallel rays for the prism? So, we have light source, light box basically, this is the light box, okay. So, generally we do not tell this is a source for the experiment, okay. So, this light is coming from this box. Now, this light basically diverging light, okay, it is emitted in different all directions. So, divergence light it is coming, and this is the collimator, So, it is this diverging light is passing through the slit. So, here already I have showed you there is a slit here, So, that slit you can adjust the width of the slit, and there is another part on it, okay. So, this type of shape. So, if you move this one on it, so basically you can adjust the height, okay. So, this arrangement is there, I will show you again. So, now so light is diverging light is entered through this slit. Now, this diverging light will fall on a convex lens. That convex lens is placed in this collimator. So, basically here this convex lens is there, and here slit is there, okay. So, when it will, so in this case the source we tell this the slit is the source for the experiment, okay, light source for the experiment, okay. So, basically whatever image you will see, that is the image of this slit, okay. So, from this slit diverging lights are coming and it is falling on the convex lens, and the other side, if I want to get the parallel rays on the other side. So, you know that this slit has to be at the focal point of this lens, okay. To place this focal point on this lens, so this part, this slit part you can move, okay. Focus knob, this is the basically focus knob, okay, like this, this is the telescope. For telescope, this is the focus knob, this is the focus knob for the collimator. So, if you just rotate this one, so slit is going out and coming in, okay. So, this way you have to place this slit at the focal point of this convex lens of the collimator. So, how I will know that it is at the focal point? So, that I will describe. So, here basically you can adjust the slit height, you can adjust the slit width, and you can move the slit in and out, okay. And this idea is to put this slit at the focal point of the collimator lens, okay. So, now parallel ray will come and then it will fall on the prism, whatever requirement for the experiment. Then come to the telescope, okay. So, So parallel rays will fall on the prism, will falls on the prism. Okay. Then due to dispersion or whatever the refraction etc. So light will come out. So whatever light will come out, so that light we have to catch, and then we can see the image of the slit. Okay. So now this from prism this lights are coming. Basically it's the parallel rays will come from this prism, parallel rays will come. So after refraction or dispersion we will get again, so parallel rays is not a single rays. So all rays are falling at same angle on the prism. So they will be refracted in, all will refracted in same angle. Okay. So that means this refracted rays will be also parallel. Now that refracted rays, these refracted rays, they will come, they are parallel. Now if I want to see the image, so either we can see at infinity or here we will use the telescope. So in telescope there is a lens, convex lens. In telescope there is a convex lens. This is the convex lens here in telescope. So let me take out this one. So this is the convex lens. So from prism, refracted rays, parallel rays are coming, falling on this convex lens. Okay. Now this convex lens, parallel rays are falling on this convex lens, so they will meet, they will converge at the focal point of this lens. They will converge at the focal point of this lens. So this is the focal plane. Okay. This is the focal plane. Now this focal plane, on this focal plane that image will form. Now I have to see this image. Okay. I have to see this image. So I will use my eye. I will use my eye. Now actually in our eye all the time this rays, say parallel rays comes, and we have lens in our eye, and they will converge on the retina. There the image is formed. Then our sense, our brain actually function to see this image. Okay. So forget this part. So here what happens? So here image is formed. Okay. So now in telescope there is another part, is called the eyepiece. Okay. So this eyepiece help us to see this image. Also it helps us to magnify this image. Okay. So in eyepiece there is a lens. There is a lens of smaller focal length. Okay, compared to this focal length. Okay. So this eyepiece, if this eyepiece, the lens of this eyepiece is put here in such a way that this will be the focal point of this eyepiece, of this lens also, Okay. Then from this lens, so this now this point source. Okay. From there this diverging light will fall on this eyepiece lens, and from there other side we will get parallel rays. So that parallel rays will enter into our eye and we will see the image. Okay. So magnification of the image is basically magnification is equal to this focal length of this lens, telescope lens, divided by the focal length of this eyepiece. Okay. So that is the magnification. So through eyepiece we will see the magnified image. Now here actually we want to uh, measure the position of the image, etc., on the focal plane. So we use cross wire. Okay. So this cross wire basically here, this cross wire it's the movable. Okay. We tell this is the focus knob. Actually what happens, this cross wire actually we have to place at this focal plane. We have to place this at this focal plane. So for that, this we have arrangement to move this one. Basically here whatever, so whatever this moving, so this crosswire is set here, So this crosswire and this eyepiece, they are separated. Okay, they are not one. So if I take, okay, this is the eyepiece, so there is no single lens here, there is a combination of lens for the so this for I think for Ramsden type eyepiece. So combination of lens are there, but it's basically simple way we can tell that's this is the function of this lens is this, and then for color it this color aberration it can remove. Okay. So this is the eyepiece. Okay. So and crosswire is inside here, So this is the crosswire. Okay. I don't know whether you can see crosswire. Okay. Okay. So so as I told you, it has three parts. It has three parts. Telescope, this is a convex lens is there. Okay. So it has a focal length. So somewhere inside here there is a focal plane. Okay. Now at that focal plane, actually I want to put this crosswire. So there basically is a screen. This is the screen. On that screen, focal plane, if I put the screen, this basically this crosswire I am putting, so that act as a screen. Then on this screen I will see the image will found. Okay. Now that image I will see through this eyepiece. Okay. Now eyepiece has again lens. Okay. So so this eyepiece lens again, so actually this crosswire is the screen which will be placed at the focal point of the telescope lens, right. So now first what we have to do, we have to put this eyepiece inside of this one and adjust the distance between this eyepiece and this crosswire. Okay, such that this crosswire will have to be at the focal point of this eyepiece lens. Okay. So that just one can see this way, just make it sharp. Yes, I can make it sharp. Okay. Through eyepiece we are seeing this is quite sharp. So I have adjusted the distance of the eyepiece from the crosswire. Okay. So you can see this crosswire is very sharp. Okay. Okay. So that way I put this adjusting the distance of this eyepiece from the crosswire. I basically focus this crosswire. Okay. Now this we will put here, we will attach here. Okay. Okay. I attached here, which part? No, this part will move. That means this crosswire will move. Okay. Eyepiece will not move, eyepiece is fixed, I will not disturb eyepiece. So, this is fixed with respect to the crosswire. Now, this way I can move the crosswire, means I have to put this crosswire, that is basically screen at the focal plane of this telescope lens. Okay. So, that is the condition to form the image at the crosswire. Okay. So, that is what different parts of the telescope, and already I have discussed the leveling screw. There are two leveling screw here. Okay. And this focus knob, this one. Okay. And I showed you eyepiece, I showed you crosswire. Okay. So, I showed you convex lens. So, next, so before doing experiment, we have to do leveling of the spectrometer. So, that already I have told you what is the purpose, why I need leveling of the telescope, because here you can see the rotation of the telescope for measuring the angle. Rotation of this prism table, I think I have to loosen it. So, rotation of the prism table. Okay. Generally we tell this vernier table. Okay. Prism table, generally this is the prism table. So, this part we tell vernier table. Okay. So, this is the rotation. Okay. Okay. So, this for this rotation, so here we need basically the axis of rotation of telescope, axis of rotation of the telescope, axis of rotation of the telescope. This telescope is rotated. What is the axis? Axis is this one. Okay. It should be vertical. It should be vertical. Okay. So, we have to make sure that axis of rotation of this telescope is vertical. Okay. Then axis of the telescope and that of the collimator should be horizontal. Axis of the telescope is this one, axis of the telescope, and axis of the collimator, this is the axis. So, this axis of telescope and collimator has to be horizontal, and also top surface of the prism table has to be horizontal. Okay. So, this is the condition for the experiment. Okay. So, before experiment we have to make sure that vertical axis of rotation and the horizontal axis of the telescope and collimator, they are perfectly positioned. Okay.